Do you want audio confirmation?
Yes.
Looks good. I see you.
Do you hear?
I'm getting sound from you from Zoom. So yes, I am getting stuff from the YouTube.
All right. So I think we're live then. So should I go ahead and start?
Yes, I think everything sounds good.
All right. So it is 7 p.m. So we're going to go ahead and start. Well, hello. Good evening, everyone, and welcome to tonight's celebration of the first official day of spring. My name is Victor de los Santos. I am the executive director of the South Texas Astronomical Society, or STARS for short. We are a Brownsville-based nonprofit organization dedicated to providing science education and community outreach in the Rio Grande Valley. Our mission is to ignite curiosity through exploration of the universe. In order to do this, we partner very often with our very good friends at the Dr. Cristina Torres Memorial Astronomical Observatory. That is where I am currently at right now. As you can see, this dome, along with a few mini domes, which we will all learn a little bit more about tonight. So brief introduction to the CTMO. It is the primary optical astronomical facility of the University of Texas, Rio Grande Valley, as well as the Brownsville and the South Texas community. The dome is operated by members of the Time Domain Astronomy Group at the Center for Gravitational Wave Astronomy under the direction of Dr. Mario Diaz within UTRGV's Department of Physics and Astronomy. So if all of that sounds a little bit confusing, don't worry. We have some awesome speakers tonight who are going to clear up some of this confusion so that by the end of this event, you will all know a little bit more about the astronomically awesome things that happen here at this observatory in Brownsville, and also why today, March 20th, 2021, marks the first official day of spring. So on the agenda for tonight, for this evening, we have talking right after me is going to be Richard Camuccio, and he's going to talk about what the March equinox is and give a virtual tour of the night sky so that so that you will know what astronomical objects you'll be able to see at night during this time of year. Followed by that will be Wendy Mendoza. She is going to cover the space science research that goes on here at the observatory, as well as some of the projects that the university's astrophysicists are currently working on. Followed by Wendy will be Alex Reyes. Alex is going to give an overview of one of the most exciting projects currently going on at CTMO, which involves an even more massive project happening right now in South America. To close off the evening will be Moises Castillo. He is going to talk about the engineering process regarding some of the really cool upgrades happening at CTMO right now. And then we will close out the event. So before I let Richard begin, I want to start this event off with a quote. I want to start this event off with a quote from this book called For Small Creatures Such as We, Rituals for Finding Meaning in Our Unlikely World by Sasha Sagan. The equinox is the astronomical way of marking spring's arrival, but depending on where you live, the weather patterns, or the flora and fauna, it might not really look or feel like spring yet. So maybe your spring begins when the snow melts, when you can go out without tights or a coat. That would be the meteorological way of defining it. Maybe you feel it's really spring when the flowers bloom and the baby bunnies are born. Those are biological events. Whatever it is that makes you feel like spring has arrived, there is a field of science that studies it and, by doing so, honors it. No matter the moment that crystallizes this change for each of us, the idea that the dark, cold times eventually giving way to bright warmth, beauty, and plenty is at the core of spring. All seems lost, but then somehow we receive another chance at life. Again, that was by author Sasha Sagan, and the book was For Small Creatures Such as We. All right, so without further ado, we are going to let Richard speak. And Richard is gonna tell us a little bit more about the spring equinox, and he's gonna provide a tour of the night sky in the spring for us. Richard Camuccio is a current PhD physics student at Texas Tech University. He is an alumni of the University of Texas, Rio Grande Valley, he received his Master's of Science in Physics there. And he's currently the Director of Science and Astronomy for the South Texas Astronomical Society. So I'll let Richard take it away now. Thank you.
Thank you, Victor, and good evening, everybody. Happy equinox. I'm really excited to talk to you about this today because I actually learned a lot doing the research on this myself. What I wanted to ask, and this is to anybody either in the chat, on the live stream, Victor, Wendy, Alex, and Moises, somebody could answer for me what they think the equinox is. When you first hear the word equinox, spring equinox, what does that mean? Do you have a way of explaining it?
So I just think equal days and nights.
Equal days and nights, right? That was Alex. Yeah, thank you. That was that's what I think everybody, including myself, thinks. So I'm gonna share my screen right now and start this. Okay, hopefully you can see this okay. So yeah, we're celebrating the March equinox 2021, and I want to take a pause for a moment and say we're celebrating it, right? There's something very interesting that happens on this day, both with astronomical in the astronomical context, as well as with humans, with us. This marks a key day in our journey around the sun. Latin for equal night, somebody said in the chat. That's right. So actually with Latin here, equinox, the word equinox. Equinoctium, I hope I pronounced that okay. From equus, equal, and nox, night, which is the genitive of noctis. And so what causes an equinox? Well, to put it simply, it's a tilt, right? The Earth is tilted in its motion around the sun. As the Earth goes around the sun, different parts receive different amounts of sunlight due to that tilt with respect to the orbital plane. So we're up here right now, essentially. We're in the March equinox, and we're in the northward progression. So it's going to get more and more daylight duration than night duration in the northern hemisphere. But a simple tilt gives us a whole lot more. For one, to reiterate it, it gives us differential heating throughout the year across the globe. But on top of that, it gives us the seasons. It also gives us migration habits, right? Birds, for instance, other different animals are following, for instance, where the warmth goes, so to speak. So they're following the warmth. If we were perpendicular to going around the sun, then there would be no change in the seasons, and the equatorial plane of the Earth would receive the most amount of light all the time. Equinox is also an apparent phenomenon. So the sun appears to move north and south in the sky throughout the year, and twice per year, the sun is in that middle part there. So this says September 23rd, that's the September equinox, but it would be in the same position, roughly, in this plot at least, just moving upward rather than downward. And so if you want to define it astronomically, an equinox is when the sun crosses the celestial equator. And the celestial equator is if you take the Earth's equator and you make it bigger and bigger and bigger and you expand it to infinity, what that looks like on the sky, that is called the celestial equator. So when the sun crosses that in the sky, going northward, it's called the March equinox, and going southward, it's called the September equinox, or the southward equinox. So that's just a little bit of definition here. But there's something interesting I actually learned a few days ago when I was doing a lot more research into this, which was that because the sun is a disk, equinox is not actually equal day and night. One, the sun is not a point source, right? We're assuming in astronomy, like the stars, for instance, they are point sources in the sky. They don't have a size. They're just a dot, right? And since the sun is not the case, when the sun sets, when that point sets, there's still a little bit of light above the horizon. So equinox itself, there's actually more light than dark. There is another phenomenon that's rarely talked about called equilux, which occurs a few days before March equinox and a few days after September equinox. And that's when there's true equality, or at least as close as it gets. So when was equinox? When specifically like the time? And when was equilux this year? So it just so happened that equinox today occurred at about 4:30 in the morning. The sun rose at 7:33 and it's going to set in about 31 minutes. This is all Brownsville, by the way, I should note. So if you're in Brownsville, this applies to you. The day length, and here's what I wanted to point out. The day length is 12 hours and 7 minutes. That's already longer than, that's not equal day and night. So what gives? Why is it called equinox? Civil twilight, these are if you're observing when the sun sets until it's about 6 degrees below the horizon. This is called civil twilight. And so it gets progressively darker until the end of astronomical twilight, when at around 9 p.m. tonight, it would be the beginning of the best observational conditions. Now, equilux, on the other hand, on March 15th, you could see here that the sun rose at 7:38 and set at 7:39, and the day was 12 hours and 9 seconds. So equal day and night occurred 5 days ago. It just so happened that that's a different Brownsville for the win. Yeah, that's right. It just so happened that this actually occurred a few days ago. So equilux is a different phenomenon than equinox. Now, the equinox is an extremely important and interesting point of reference for humans as well. And I think it wouldn't be fair to ignore this part of it about the equinox, because this is part of being human. There's something that is about astronomy that brings different people together. And I wanted to take a tour of that real quickly. But real quick, I wanted to say that the astronomical definition of spring is March equinox. So spring, from an astronomical perspective, began today. A little bit different than other definitions of spring throughout the world, which we'll see. That the March equinox is the 0 point for the sidereal time, which is the calendar that's linked to the motion of stars rather than the sun or the moon. You can have lunar time, lunar calendars, you can have solar time. And then you can also say, okay, if there's a group of stars in the sky at this time of the year, how long until that group of stars comes exactly back? That's considered a sidereal year. So sidereal time 0 point, when we start the next sidereal year, is on this day. Now, the point of northward crossing, since the sun is now getting more and more north in the sky in the northern hemisphere, is called the first point of Aries. And so Aries was the constellation when this was established, that through which the sun was passing on the March equinox. But right now, it passes through Pisces. And in the year 2600, it'll pass through Aquarius. Now, Aquarius, why is it not in Aries anymore? Well, the Earth precesses like a top every 26,000 years. So that's the reason why, for instance, the North Star used to be Thuban, now is Polaris, and someday will be, I forget the third one it's going to be next, but the North Star changes, as does the constellation through which the equinox occurs. And so a lot of cultures and religions use it as a reference for calendars and celebrations, which I'd like to share for the next 6 minutes or so. So let's just go through this. I think this is pretty interesting myself. The Jewish Passover usually falls on the first full moon after March equinox, sometimes on the second full moon, depending on the calendar year. In Christianity, Easter is calculated as the first Sunday after the first full moon, on or after the March equinox. That's a precise definition there. It just so happens that the Eastern Orthodox Church uses the Julian calendar, and the Western churches, including the Catholic Church, use the Gregorian calendar to calculate it. And so this is why we have two Easters sometimes, because there's two different calendars being used. Then there's Novruz, or the Iranian or Persian New Year, which begins on the March equinox. It's the first day of Farvardian and the first month of the Iranian solar calendar. Celebrated in Western and Central Asia, the Caucasus, the Black Sea basin, the Balkans, and South Asia. So it's based on the solar Hijri algorithmic calendar, which is based both on precise astronomical calculations as well as a more sophisticated way to update the calendar due to errors accumulated over time. This is making it more accurate actually than the Gregorian calendar that we use. So this right here is a low relief of the eternally fighting bull, the earth, and the lion, the sun, with equal power in this particular depiction, which this is the depiction of the equinox from the Persepolis temple in Iran. And also in the same Novruz, excuse me, this is a depiction of the mythological king of Persia who ascends the throne and takes his place as king, which took place also on the March equinox. So a lot of important things are going on. And I was joking with my friend earlier that, you know, people get pretty interesting around this time of the year. Humans in general, we all are tied to the stars here. So then there's Sham el-Nisim, the Egyptian New Year, which is one of the oldest holidays still in practice. It can be dated as far back as 2700 BC. And it was moved to the Easter Monday after Egypt was Christianized, and previously it was on March equinox. So, and they seem to paint eggs, which is a theme that everybody associates with this time of the year. Similarly, around the world, you have, for instance, the Latvian tradition. These are Latvian painted eggs. In Scandinavia, before, again, Christian influence, you have the Nordic tradition of Disa Blot. Blot is a sacrificial holiday, and Disir is basically emphasizing the female or feminine spirit. So it's actually honoring females in this sacrifice here. I think they're just burning torches and they do a lot of chants. So it's pretty interesting. There's the drowning of Marzana in Poland, who is a Slavic goddess. So this is interesting. I wanted to read this actually because I think it's kind of crazy what they do. Basically on the equinox, there's traditionally children will carry this through the village and dip it in every puddle or stream they find. Then it's passed to young adults in the evening and carried out of the village, burned and thrown in the water to get out of the village. And for the superstitious, one cannot touch it once it's in the water or your hands will wither. And one shouldn't look back after you're done throwing it in the river for the entire way home because you might get ill. And the Catholic Church tried to ban this in 1600s and they failed. Nobody wanted to stop doing it. So they do it to this day. Very interesting on the equinox. And then, okay, so let's go to the Americas. So there's El Castillo at Chichen Itza, which was built during the terminal classic period of the Mayan civilization. And this demonstrates the descent of the snake, which occurs only on the March equinox. So this pattern that goes down the side here. Here's a night rendition of it. It's artificial here, but it shows what that phenomenon looks like. The Pyramid of the Sun in Teotihuacan. Sorry, I butchered that too. People migrate to this pyramid and ascend it predominantly between 9 and 1 p.m. And they typically wear white with red scarves, they dance, they burn incense, but it's only on this day. And then finally here we have the Cahokia Woodhenge, which is near Collinsville, Illinois, and it's a large timber circle located in the Mississippian culture Cahokia archaeological site. So here's Cahokia here. So it's in southern Illinois. And one thing about this is that there's no rituals or celebrations performed at all out of the respect for the Native Americans, because they did not do anything in particular on that day either. So, so there's nobody really accumulating there. But I think this was my favorite one, to be honest. So we have a henge as well. It's not just in Great Britain. And so real quick, it's also World Storytelling Day, an oral tradition of storytelling, which is celebrated. It's the oldest way we tell stories as humans. If you live in Annapolis, Maryland, there's the burning of the socks ceremony, which occurs on this day, and it's to end winter. Basically, we don't need socks anymore. It's basically summertime, I guess, and it's a boatyard and sailing tradition. It even warrants Google drawings. So this is from 2016. And this is all because the Earth is tilted with respect to the sun that we have all of this. So I'm out of time. Thank you very much for your attention. And I hope this, if we have time later, I can give a little bit more detailed tour of the sky. But I'll just say real quick that Orion dominates this part of the sky, and at least in the south. So Taurus, Orion, and a few other, like if you're looking south right now, Orion's in the sky, the moon's above it, Mars is above it, and Sirius is to the bottom left, and Aldebaran the bull, Taurus the bull with Aldebaran's eye is up to the north here. So these are the main features, and if there's more time later, I can go into more detail. But thank you for your attention.
Hey, Richard, you still have about 10 minutes if you want to give a tour until 7:30.
Oh, really? I thought it was 9 to 9:20. I thought it was 20 minutes.
No, sorry, I took up the first 10 minutes, so you can go ahead.
Sure. Okay, that's great then. First, I mean, if there's any questions, by the way, again, I have the group chat open, or the YouTube, the YouTube chat open. So for anybody who has questions or wants to interact with us, please do. So here we're actually in Lubbock, but the only difference between Lubbock and Brownsville in this situation is some of these stars are going to be shifted, or the sky is going to be shifted a little bit more north. So the same features apply for Brownsville, basically. If you're standing in your backyard like right now, basically, it's still too bright to see any of this. So I'm going to advance in time to about, let's say, 9 o'clock when astronomical twilight ends, something like that. Okay, so if you're standing outside at 9, you'll start to see a lot of this pop up quickly, but basically Orion is over here. Orion is going to be the primary constellation you're going to see in the sky, at least in the south. Betelgeuse and Rigel being the big stars, and M42, the Orion's Nebula, part of a sword, being the prominent features. And then there's Monoceros and Canis Minor, which Procyon being a nice reference star. So Procyon, Betelgeuse, and Sirius down here from Canis Major, excuse me, form a nice triangle of reference. And that actually triangulates the galaxy. So if you see this kind of like lighter band right here, this is the disk of the galaxy. This brown line, the galactic equator, kind of showing you geometrically where it is. And so this triangle right here overlaps that and gives you a nice reference. So if you're looking in the center of that triangle, you know you're looking into the disk of the Milky Way there. Right now, the moon is pretty high in the sky, and it's illuminated almost 45%. So it's on its way to first quarter. And then Mars was in a near conjunction with the moon, being it was at the same lateral point along the sky, either underneath or above. Mars itself is moving more west, or I should say the moon is moving more east. So there's more of a difference between them now, but a few nights ago, they were really near each other. So up here, there's a lot of cool stuff happening too. This is all along the ecliptic, by the way. So this is where the orbital plane of the solar system is. And when you look into that plane, you should see planets and asteroids. So the moon is here, Mars, Aldebaran, the Pleiades, and then Uranus being a little farther down in the sky. It's setting at this point. All of these things are right above you here. Check this out, Aries over here. This, I don't know how long ago it was, but originally it would have been all the way over here. So because the Earth precesses, that shifts in the sky. So it used to be in Aries. And now the equinox occurs in, well, actually it's not up right now, but Pisces. So now if you look to the east, Leo is on the rise with Regulus. Again, Procyon, and a lot of clusters. There's a lot of neat clusters along this plane here. Pollux and Castor with Gemini, which is above Cancer. So Leo, Cancer, and Gemini are along a plane of ecliptic going down into the east. Okay, so as for the northern sky, well, the northern sky is rotated. It's always going to show these same constellations, more or less, especially these upper ones here, but it's upside down. So like in Cepheus is down here along with Draco, whereas in like the fall, for instance, they're up here, and they're going to be on the rise more and more now. Cassiopeia the double cluster, which is awesome to see if you have binoculars. And Ursa Major with another, there's a visual binary star in the bend of the handle of the Big Dipper here. So you could check that out. You might even be able, if you have really good vision and a good night, you could see it just with your eyes very faintly, but binoculars will clear that up really easily. And then of course the North Star being Polaris. So as for meteor showers, I didn't have time to look into it. I don't remember exactly, but there are always meteor showers occurring, just not the prominent ones necessarily. So does anybody have anything they want to say, by the way, like either in the Zoom room or online? I want to make sure that everything is clear and there's no questions. Well, yeah, that's pretty much it then, unless there's, is this the dawning of the age of?
I have a question perhaps.
Go ahead.
And it might be fruitful for everyone. So, hi, I'm I'm here. I guess the question is like maybe if I like this is my first time ever seeing these kinds of things. Like I want to go outside and look at these things that you're talking about right now. And
right.
I don't know, is there something I can do or like something I can reference maybe on my phone? Right.
Oh yeah, absolutely. Let me actually get it up here. Well, right now there's two things actually. What I'm using is the Stellarium right here. This is free and it's cross-platform. So if you have any operating system, Windows, Mac, or Linux, you can download this for free. And I have it actually a lot more detailed than it comes by default. So if you want to get into navigating the basics of the sky, this is a good start for the computer. And then as for the phone, I'm using Skymap. So Skymap is this nice, well, I think I have a thumbnail right now, but basically Skymap or any of the, there's a bunch of different planetarium software you can get on the in the Apple Store or on the Google Play. So definitely, that's a good point. And those you could just point at the sky. It just fixes your GPS. Google Night Sky app for Android. Yeah, that's what I use. And yeah, April 4 Lyrids, by the way, that is true. I didn't think about that. So yeah, good questions. Is this the dawning of the age of Aquarius? I guess in the sense of the equinox, yes. Were there other questions? It's just 2 more minutes.
What's your favorite spring constellation?
It's your favorite spring constellation.
Orion.
That's right. Yeah, Orion is my favorite.
So, yeah, Orion, correct me if I'm wrong. Orion comes out in the southeast right now. So right now it's actually up over the horizon. I think in the southeast, just not visible because the sun is still out. But once the sun goes down a little bit more and it gets a little darker, we should be able to see Orion. You should be able to see 3 stars. And if you know what the constellation looks like, Orion the Hunter, you can see where his sword is and how he's actually kneeling down. And I think there's even an option on Stellarium to see the constellations, right? And you can actually see the nebula. Yeah, that's one of my favorite objects to view is the Orion Nebula, because you could see it without even using it. Obviously, telescope and binoculars make things a lot cooler, but the Orion Nebula is an object that you can see without binoculars or a telescope.
Yeah, so right now, actually, it's what's called transiting. So it's transiting the meridian right now, which means it's at its highest point in the sky currently. And so after the sun sets, currently it'll be on the descent, but it'll still be visible for several hours. There was a couple of things being said here. What is the guitar cluster? Well, I don't know. I think that's where fenders are made, but I could be wrong. Electric guitar cluster. Let's go there.
That's where all the live shows are happening right now.
That's where the live shows are happening, right? There's plenty of safe distancing, a few kiloparsecs from each other. So yeah, this is an
Stellar
open
distancing.
this is an open star cluster. So real quick, this is a type of object that it's a young cluster, and these are stars migrating outside, like they're all migrating away slowly over time. So that's what these are. But anyway, yeah, good questions, everybody. Thank you.
Yeah, thank you, Richard. All
Yeah,
right.
no problem.
All right, awesome. Well, thank you, Richard, for being an amazing first presenter. I always get excited when Richard presents. So our next presenter is going to be, our next presenter is Wendy Mendoza. Wendy is a graduate student in physics at the University of Texas, Rio Grande Valley, and she is also the assistant director and lead astronomer at the Cristina Torres Memorial Observatory. And she's actually shooting live from inside the observatory right now. So I will hand it over to Wendy, and she is going to tell us a little bit more about the science going on here in Brownsville, here at the CTMO.
Hi, everybody. I'm here at CTMO. Let me just share my PowerPoint. So, okay. Can you guys see my PowerPoint? I don't think so. Okay,
No,
let
no,
me
no.
see. Go. Okay, so what about right now?
Yes.
All right, awesome.
You're good there.
So in astronomy here at CTMO, we don't only take beautiful pictures. We do that too, but we also do science. And Detector, this is the Cristina Torres Memorial Observatory. It's located at the Resaca de la Palma at Brownsville, Texas. And we have researchers here, undergrad and grad student as well. And we use this basically dome to do research, educational tools, as well as outreach. So this is mostly operated by the Time Domain Astronomy Group for the Center of Gravitational Wave Astronomy under the director of Dr. Mario Reyes. So here, this is a beautiful picture of the dome that we have. This is like a very nice telescope. It's a reflector, 17-inch optical telescope. And which reflectors do, it works under the principles of reflections using mirrors. And we do use a camera as well. It's called a CCD, which usually it's right here. And I'll talk about the CCD, what it is, because CCD is one of the most important one of the important instruments that we have to learn, and we have to be really, really careful to use it. So one thing about the reflector telescopes, so this is how it looks on the inside. Let's say that I want to take a picture, observe the moon. And once we observe the moon, like all the moonlight will reflect towards the primary mirror. So the primary mirror will gather all the colors, all the light, and then it will reflect toward the secondary mirror. So this is the secondary mirror. So once the light of the moon reflects to the primary mirror and goes to the secondary mirror, it will go into the eyepiece, which we don't really use eyepiece here. We use the CCD. So a little bit more about the CCD. Astronomers use CCD, which is a charge coupled device. A CCD are sensors used in digital cameras to record pictures or moving images, and everything has a CCD. If iPhones have a CCD, the laptop have a CCD. So they come in different sizes. The one that we use is basically a little bit bigger than normally the ones from the iPhone. So what the CCD does, it basically consists photodiodes, which converts light into an electrical current. And what is special about these photodiodes, this comes with this. So this is a picture of a CCD, basically. And all these little here rectangulars have are named to be pixels. So all the light will capture into these rectangulars, and this will convert into a signal, which are known to be counts per pixels. So this is where we gather our science data from observing through a CCD and a telescope. So one thing I do want to talk about is about the time domain astronomy. So time domain astronomy is the study how astronomical objects changes in time. So one of the examples of the time domain astronomy targets that we observe near Earth asteroids, binary stars, exoplanets, galaxies, supernovae, transients, active galactic nuclei, occultation, comets, and many other more of this astronomy targets. But there is an observational plan when we do this type of science. So first of all, we have to know the telescope time. There are different people. We do have different observers from Monday all the way to Sunday doing observations. So it's very important to know what time and the date someone's going to be here to do the observation. We do plan ahead. It's very important to plan ahead because we don't want to waste time on something that, let's say if I have an object and I don't know, something happens or someone is observing, then it will be impossible for you to observe an object. So it does come with some factors beforehand. And one of the factors are target, weather, and location. So let me talk about the target. So when we observe a target, let's say any planet or any galaxy, any asteroid, we have to know beforehand, we have to choose the target that we want. And we usually look at previous data as well from other observatories who have taken data from that target that you're interested in. And we have to know the brightness, which is the apparent magnitude. And this comes about the apparent magnitude is probably one of the most important things as well. So let's say this is a perfect example of the brightness. So this is a measurements of the apparent magnitude. And this is an example of any other targets that, let's say, that you want to choose when you observe. So if you want to choose the sun, the apparent magnitude is going to be around the negative. So that means that everything that is negative is going to be way too bright and it's going to be really good for you to observe. If you want to observe like a galaxy, let's say I want to take data of a galaxy, we have to know the magnitude as well. Anything that it's 20 or increases, anything that is 20 or more, that means that the target is way too up high on the sky. That means that it will be impossible for our telescope to capture that much light. So for target, for the apparent magnitude, we use the magnitudes between, I don't know, all the way to negative, the negatives all the way into the 20s or the 19, magnitude 19. That's how much our telescope captures the light. Another thing is the location. So I know Richard mentioned about a stellarium. There are other apps that you can find. There's like Skymap, I have it in my iPhone. But mostly astronomers, we use the stellarium. This is where it helps us captures the position where it's going to be our target. So another thing I would like to talk about is the azimuth and the altitude. So the azimuth and the altitude are basically dependent on the location of the observer. So is it dependent on the location where I am right now? Let's say I want to observe the moon, and that's where I am right now on the azimuth and the altitude. So the azimuth is the angle of the object that makes the horizon. So if you look here into this data, here it even tells you like the magnitude of the star, the type of the star, the apparent magnitude, and here you go right here, this tells you like the azimuth and the altitude. So if our altitude is below the 30 degrees, it will be impossible for us to observe. So our target has to be higher than 30 degrees in order for the telescope to observe it. And one thing to keep in mind as well, we do record the right ascension declination, J2000. This is the thing that we use the most. So the right ascension declination is an angular distance measured eastward from the vernal equinox. Basically, the right ascension is usually measures like in hours, minutes, seconds, or rather than degrees. And then we have the right ascension, the declination, I mean. So the declination is the angular distance of above the object or below the celestial equator. So this is the information that we use. We use the perimagnitude, the right ascension declination, and the azimuth and altitude to plan our observation. Next, this is the one that every astronomer struggles the most. So it's the weather. So weather plays a very critical role based on optical astronomy, because we do have to observe in the sky with, with our telescope, and it's very important to protect that telescope from that weather, from anything in general. So we go to this website. It's called the weather.gov, and we use it all the time. Every single day we check the weather before observing. And one of the main things that we do, we check the sky coverage percentage, the rain, of course. If there's any rain or any thunder, we cancel observation automatically, and the service wind. So sky coverage can be an issue as well, but anything that it's depending on your magnitude. So I talked about magnitude. If your magnitude is 20 and the sky coverage is 50%, that means that it will be impossible for the telescope to capture that magnitude. If my magnitude of the target was like on the negatives, let's say like the -20, and my sky coverage was 50%, then yeah, it will be possible to observe it. So rain, thunder, and sky coverage, it's a big issue for us. So this is some of the beautiful image that CTMO has taken. Students here at the observatory have the neowise, the whirlpool galaxy, the moon. So it's M101. Very, very beautiful images that we take here, and we like to keep them safe. So let me talk about the science behind the astronomy. So we use light curves, which obtains the collection of observational data on transient targets over time. So this is where optical astronomy, and this is how we read our data when we take any type of data, honestly, any type of, when we observe any type of target. So if the object changes brightness over time, you can get enough data and you can plot the changes against time. So once I'm going to show you like three examples of what we've been doing here, and you're going to see a lot about this graph. You're going to see the time, depending how much time we have taken that data, and depending the brightness, which is like the magnitude. That's why I mentioned about the magnitude. So one of the examples that we've been doing is the follow-up of M31 NOVA AT 2020 AAPW. So this is known to be a transient. Transients are observations, are astronomical objects whose duration may be from seconds to days, weeks, or even several years, which is something visible in the sky for a period of time. So last November, a star exploded in the Andromeda galaxy. This is the data we collected from the observatory from the explosion, which is called a nova. At the CTMO, we took images of the nova over a week. It's been like a week or 2 weeks, and this is the light curve that we got from the data. So this is the time, how many times that we taken, and this is the brightness of it, which is this magnitude. Another one of our researchers here, his name is Martel Valencia. He has been taking the active galactic nuclei, and active galactic nuclei are basically like compact regions of the center of the galaxy. This central regions emits a tremendous amount of light across the electromagnetic spectrum. So the whole purpose of the Martel is doing this is because he's trying to get light curves, which is important because it tells us how the incoming light flux over time. So this is a very crucial because the flux can be caused by interesting phenomena like merging black holes or binary neutron stars mergers. So this is a left image of the SDSS, basically an image from a catalog on the website, and this is an image from CTMO. And this has been taken by filters. Next, we have asteroids. So this is kind of like my thing. I love asteroids. It's one of the most easiest and funnest ways to do. And the whole purpose of doing this is because we're trying to, of course, get data from a near Earth asteroids and discover them and know their composition and know what's going to be, it might hit us or might not hit us. So this is one of the asteroids that I observed. It's called asteroid 2006 NL, and it was taken in July 2020 from 2 days, and it's classified as a near Earth asteroid. So here you can see its magnitude as well, how it drops. And here you can see like the dates as well. So the next approach of this near Earth asteroid is going to be in July 12, 2027. So this is a video that I made. And here you can see from the time, the 2 days, been observing like for, let's see, I don't know, I think I remember it's like 4 hours every day. But yes, that's the asteroid. Okay, guys, so thank you very much. This is the science that has been going on here at CTMO. And you have any questions, please let me know.
So what kind of information do you get from things like asteroids and other transients?
What kind of information do I get?
What does the data mean? The light curve data. What can we learn from that?
The light curve data, we learn about basically this brightness over time by getting two comparison of two stars.
Cool. Does anybody else have any questions for Wendy before we switch over? I'm checking the YouTube live stream.
Great, no questions. I need to go to the restroom.
Okay. Well, thank you, Wendy.
Okay.
All right. So we're going to, before we move on to our third presenter, I want to share my screen pretty quickly. So, I want to, before the event, we, on the flyer, some of you might have noticed that there was going to be a raffle fundraiser. Due to some rules that were brought up to us, we were not able to actually host that raffle fundraiser tonight as promised. But however, if you would like to support STARS and the programs that we are doing with the CTMO for education and outreach, please consider donating to us by heading over to our website at the www.starsocietyrgv.org and click on donate at the top. Alternatively, you can also click on store, and we have a few new shirt designs here and some other merch that you can purchase if you'd also like to support us in this way and get something back. So this is the shirt that I'm currently wearing right now. This is the STARS Classic shirt. We also have our new special edition Gateway to the Cosmos shirt. This one includes a really cool design designed by our very own Brina Martinez. And we also made that awesome design into a sticker. So we have some merch there on our site. If you are able to, if you'd like to support us and walk away with some cool merch, we will get that delivered to you. So there you go. So now, without further ado, I'm going to introduce our next speaker. Our next speaker is Alejandro Reyes. He is also a graduate student in physics at the University of Texas, Rio Grande Valley. And he's a researcher and one of the lead programmers here at the Cristina Torres Memorial Observatory. Alex is going to give us an overview of one of the most exciting projects currently happening at the observatory. So Alex, take it away.
Hi, can you hear me?
Yes.
Great. Thank you for the introduction, Victor, and make sure to save me one of those stickers. So great talks, also Richard and Wendy. So Hi, again, my name is Alejandro Reyes, and I'm going to talk a bit about the Vera Rubin Observatory in my presentation. So first, for an outline, first I'm going to introduce the Vera Rubin Observatory project. I will talk about the data analysis pipeline and the challenges that the team is facing at the moment. Then I will conclude by showing how the Vera Rubin Observatory and CTMO's goals align and how we can integrate the pipeline to our work. So here's an image of the Vera C. Rubin Observatory. The construction began in 2014, and it is still undergoing construction. I really like the design. It just looks very futuristic. The location, it is being built on the Cerro Pachón in the region of Coquimbo in Chile. The region was chosen, you can see here, because of the high altitude and because of the climate. It's very dry, and you want to minimize the astronomical seeing. And seeing is just a measurement of how much your image is disrupted due to turbulence in the wind or the atmosphere that stays in the way between the object that you want to see, the object of interest, and your telescope, your camera. This observatory, it is named in memory of Dr. Vera Rubin, and she did work in the 70s studying the rotation rate of galaxies, and she noticed that galaxies actually spin a lot faster than theorized, than they were expected to spin. And this led to evidence of the existence of dark matter. With that in mind, one of the science goals of the observatory is to study dark matter. One of the ways to study this is through gravitational lensing. You can see here, this one is a simulation of what gravitational lensing is, which is the bending of light due to massive objects standing in the way between us and the light source. And this one is a real image. This is I believe it's a cosmological horseshoe here, which is two different galaxies. It's just that one is in front of the other. And you can see the lensing here. Another one of the goals for the Vera Rubin Observatory is to map small objects in the solar system. So small objects such as asteroids. You can see here the Tutatis asteroid. I hope that pronounced that right. This one image is taken from the European Southern Observatory in 2004. And other types of small objects in the solar system could be lying in the Kuiper belt. These are 5 interesting objects taken by the Hubble Space Telescope. Now, a third science goal for this observatory is to detect transient phenomena. And this is where CTMO can come in and help in corroborating these findings. So once the telescope finds one of these detections, it will send automatic alerts to the public, and we can then follow up these transient phenomena. So events that happen once and then fade away in time. Some of these include supernova explosions. So at the end of a star's lifetime, you have the star collapse and emit enormous amounts of radiation, and also gamma ray bursts, which can also happen at the end of a star's lifetime, or some can be, it's thought they can be attributed to the merger of neutron stars. So neutron stars are orbit each other and then merge together. And then a fourth science goal of this observatory is to map the Milky Way. So this one here is this is actually the Andromeda galaxy, but it's just to illustrate the idea of tiling a mosaic of the sky. So taking several images of different portions of the sky and then put them together so we can see a large field of view. Now, with all these goals in mind, the Vera Rubin Observatory is going to create and populate the Legacy Survey of Space and Time, which is a survey. It's basically a database that will hold all the information, all the images taken by the observatory. There have been other surveys in the past, such as the Sloan Digital Sky Survey, which saw the took images in different filters. Another example of a survey is the Pan-STARRS. This one focused on small objects and detecting and tracking small objects in the solar system. And another one is the Zwicky Transient Facility, which works in detecting transients and sending out alerts as well. So the Vera Rubin Observatory, or LSST, will do a similar work as these previous surveys. Now, there are challenges that come with such a large instrument. We're talking about a 3.2 gigapixel camera, and that means 3.2 billion pixels are going to be laid out in this sensor here in the back of the telescope. Here's half of a person that I had to crop just to fit it in the presentation. But this is just to get an idea of the size of this camera. And it is planned to take 3 15-second exposures every minute. What it will do is take a 15-second exposure, then it has 5 seconds to reposition, and then take another 15-second exposure. And that's 5 seconds of moving, and then you still need some time for the telescope, for the whole frame to settle in, stop moving completely, and then you can take the image. So it will be monumental just to move this whole thing within 5 seconds. Now, it is expected to put out 30 terabytes of data every night. For comparison, the SDSS, the Sloan Digital Sky Survey, was taking 200 gigabytes worth of data every night. So we're talking 30 terabytes or 1.28 petabytes. That is over 1,000 terabytes of data every year. And it is set to run for at least 10 years. And it will map the southern sky, so its whole field of view, about once every few nights. So these are huge numbers of data. And how do you store such big files and do analysis on them? Well, you build a pipeline. So what is a pipeline? Just a tool that takes raw data, your raw images, it runs a set of actions in it, and then it outputs desired information, science-worth information. And the actions that it performs can include sorting the data, so putting in the right folders or in the right places within a database, calibrating the images, so making sure that the stars that you're looking at, the galaxies that you expect to see in your frame, have the appropriate levels of brightness, and performing light curve analysis, different types of analysis. And the plan for LSST is to issue transient alerts within 60 seconds. So once it takes an image, it will scan the whole image, the whole field of view. And if it finds something that was not there before, or that is not supposed to be there, it will release an alert, a public alert for other observatories such as CTMO to follow up. And it is expected to release around 10 million alerts every night. So it will be unfeasible to have someone or a group of people working on this every night. That's why you need a pipeline just to automate these processes. So the current status is that the LSST team is developing a pipeline called the Stack to tackle big data. And it is designed to be implemented in different observatories around the world just by tweaking the code. So basically telling the pipeline that exists, what your camera specifications are, what type of images you take, the size, the filters that you use, and then just feeding your data into that pipeline. This is so that your analysis can be also time efficient, or if you're taking a lot of images, they can be automatically sorted, cleaned, and you can do the appropriate analysis on them. So one of the observatories that has already implemented the code is Japan's Subaru telescope in Mauna Kea in Hawaii. And the current goal for CTMO is to also implement that code to work with our data. So we're working to adapt the LSSD stack to be used with our images. And the current steps include teaching the stack how to read the images, so what camera specifications to expect, and the format and the information contained in each image, and also the calibration to be done. So for the future, the goals include a pipeline which knows how to read CTMO images, to do cleaning, calibration, and analysis of the data, and for all these processes to be done automatically. So one night you can go into the dome, just take a few images, and as you're taking the images, have the pipeline already sorting them out and cleaning them and giving back the graphs that you need. So as of now, Martin Berois has adapted and tested a test bed to be built upon. And the programming team here at CTMO includes graduate students Victor Perez, Wendy Mendoza, Abigail Martinez, and myself. And also some acknowledgements to Moises Castillo and Victor de los Santos and other researchers at the CTMO group. So any questions?
I have a question.
Go ahead.
You said that there's 30 terabytes of data per night projected from Vera Rubin, right?
Yes. Yeah.
How does that compare to, like, for instance, the average daily data generated at CTMO, for instance?
Ooh. Okay. So I have a USB that's 32 gigabytes of space, and that one I can fill that up maybe with 2-3 nights. But also depends on how long you want to look at something for. So if you're looking at, say, a variable star, you want to be pointing your telescope at it for at least maybe 2 hours, if not a lot more, depending on how long it takes for a full cycle of the star to go dim and then bright again. So yeah, maybe we could put out, I think, maybe 5 to 10 gigabytes of data a night, just for comparison.
Great, thank you. And great talk, thank you.
Thank you.
So did you mention what the current timeline for the Vera Rubin Observatory is right now, since it's still not fully operational yet, right?
Right, yeah, no, it's not yet. And let me show a picture or comment on it. So this is an image taken at the beginning of this month, at the beginning of March. And they already have the housing and everything. They still need to put the camera, at least by the beginning of March, they still needed to put the camera in the dome. They plan to do first light. So they plan to take the first images this year, later this year.
Cool. So our good friend Keith Bowler asked, can you talk about the signs to know if a star is going to go supernova so that you can plan the observation ahead of time?
Ooh. So that's a good question. Hey, Keith, by the way. I believe no. So you can tell a star is late in its life cycle just by seeing doing spectroscopy analysis of its light, the light coming from the star, seeing what elements it is composed of. But the actual timing of the supernova event, that we cannot know. I heard a number for, I believe it's Betelgeuse, that will go supernova soon, but we have just a wide range that goes into the millions of years, if I'm not mistaken.
Yeah, and I think Keith knows a lot about Betelgeuse too. I think yeah, Betelgeuse was a star that I believe last year a lot of people thought that it was going to go supernova because it started dimming, and we know that Betelgeuse is, I think, closer to the end of its cycle, but it turned out that it was just a variable star, so everyone on Earth was tricked.
Could I also add real quick that, like, there is no, as far as I know, no model about supernova that the star gets dimmer before it goes boom. You could get a neutrino pulse detected by IceCube in advance, but that would only be a couple of minutes, I think.
See, by the time you look at it and do some analysis where it came from, I'm sure we would already see the light of the supernova event. It's interesting.
Maybe one day we'll figure out how to get them before they come out.
Like the Super Kamiokande picked up supernova 1987A, its neutrino burst beforehand.
Wow, that's cool.
Great. Do we have any more questions? I'm looking at the YouTube chat right now.
Oh, I'm not sure. Did you mention what particular maybe programming languages? Maybe there's a programmer out there that's listening. What programming languages that you're using?
Yes, so primarily we're using Python to implement the stack, and the stack is written inside of a Docker container. If you're familiar with Docker, it's basically running under Linux, but separately from your computer's kernel, and so that's how we're writing the code right now.
Cool.
Awesome. Well, thank you, Alex.
Sure, thank you.
Yeah, the Vera Rubin Observatory is one of the biggest astronomical projects happening in the world right now, and so it's really cool that CTMO and UTRGV are going to be able to work with them and play a small part in that, and possibly build a science collaboration with them. One of the main focuses at the observatory here, our good friend Tim Berry helped us with some lighting because it got a little darker than we were expecting here. But yeah, one of the biggest collaborations we have going on at the observatory is with LIGO, with the Laser Interferometer Gravitational Wave Observatory, and that's how this observatory currently knows about transient multi-messenger astronomy events. And so with the Vera Rubin Observatory and those 10 million alerts per night, well, hopefully there'll be a lot of other opportunities to get some really cool data from here and to do some real groundbreaking science right here in Brownsville. So thank you. So to close this off, it's a little bit darker now, but you might have seen earlier, there you could see here right behind me again is the Cristina Torres Memorial Observatory. And then out there is right behind it, there are 9 miniature domes. So you might see 2 or 3 or 4 from this angle, but there's 9 miniature domes right now. And so there's a lot going on here at CTMO, not just on the science side, but also on the engineering and construction side. And so to finish off tonight, we're going to have Moises Castillo talk. Moises received his Master's of Science in Physics at the University of Texas, Rio Grande Valley. He is an engineer for the CTMO, so he helped put a lot of this together. And he has been with the Center for Gravitational Wave Astronomy and the Time Domain Astronomy Group for a very long time. And so Moises is here to talk about the future of CTMO.
The of CTMO. So thanks, Victor, for the introduction. So yes, I guess it's my turn. And what I'll do now then is I'll share my screen, and so I can show you some pictures today. Also, I'm assuming that you can hear me. Yeah.
Yes.
All right, that's great. Today, I'm gonna be guiding you through a story, right? And the story is that of the engineering that's happened here at the site at CTMO. And so let's see. Here we are. So CTMO update engineering status. And so let's go ahead and get started. I know we said we will talk about the future. If you've seen the advertisements, right? It says there, CTMO the future. But I think to get a good grasp of the future, we're going to be looking a little bit at the past. So let's start from 2007. Here's a paper clipping of the Brownsville Herald, right? We check out the date. I look really closely by squinting my eyes, but I'll read it for you right here. It says Wednesday, August 22nd of 2007. It says eyes on the sky. So here we see Mario Diaz and engineering students, Antonio Galan and friends Guillermo Valdez, which these guys are doing awesome stuff. Now they and Guillermo, I know, has his PhD, so hello Guillermo, you're watching. And yeah, so at the time it was a legacy institution, UT Brownsville and Texas Southmost College. And so this was the observatory, the physical dome, the shell, setting up. And yeah, then I'm gonna skip forward several years where to 2014 when a new partnership was formed. So the observatory had been set up there. It was on the Brownsville campus of UTRGV, and there's new construction that was going up. It's downtown, terrible light pollution, not that great, of an observation site. It's an amazing learning tool, anyways, but it's not so good for doing real nighttime observations and trying to do research. So kind of humble beginnings. This image is taken at Resaca de la Palma State Park. Antonio Galan was walking around looking for a new potential site, and they saw him walking around after hours at the park. They struck up a conversation, and then after that, now it's history, right? So this is the site, the actual location of where CTMO now is. And so there's just the telescope with a tripod. So in 2015, we had to pack everything up. The dome was completely stripped from all its walls. And as you can see, that building that's pictured on the left is the Brownsville Early College High School, BEX. And you can see they also have these lights that are, I mean, if you watch the podcast, right, I talked a little bit about this, or if you watched or heard the podcast, so right, shameless plug. The Stars podcast, I was their most recent invited guest for their last episode right now. And yeah, so here we see some students working on the observatory. So this was a pretty big deal for us, a very big move. It is labor intensive as well, and it has to be all very carefully orchestrated so everything can be done in a safe manner. So in 2016, here we are. We have new beginnings. This is now the concrete pad where the observatory currently sits. So if you were to visit, you would see here you could actually peek through the window, through the door that you would be approaching when visiting CTMO, and there is the sidewalk, right? So we're like on the rear entrance and yeah, so it's empty. There's no telescope, and that's essentially when I got on board. I'm not pictured here, but this was the installation of the pier. Actually, they call this piece here the pedestal, and the pedestal is something that's incredibly heavy. And you see here they use a chain hoist to lift it up. And pictured from left to right, there's Raul and Carlos, two Argentinian men that helped us so much. They're amateur astronomers, and in the true sense of amateur, they are amadores of the passion in astronomy. And so they have a real practical sense in terms of what it means to be an observational astronomer. And so they were invited, and they helped us out doing the installation, and they also taught us how to rough it as an astronomer. Just another plug there. Then there's Irvin. Irvin is one of our or was one of our group members, and he had been very active with us for a really long time. So a lot of the setup is also thanks to him. And and on the far right we have Mario Diaz. He is our advisor and director for the Center for Gravitational Wave Astronomy and the director for the Cristina Torres Memorial Observatory. So the mastermind, right? All right, so 2017, fast forward, right? We have the telescope, we have set up, and now we're using a camera, but then we got a new camera, and with new camera we had new problems. This is essentially the story of any observatory. It's kind of like growing pains, but also aging pains. There's things that just like you continually need to be working on. So in this case, we got a new camera, and we got this awesome filter wheel for it. Yeah, it ended up being actually a little bit too heavy for the focuser. The focuser that we had was an electronic motor that would move the camera and the filter wheel back and forth. But it was just a little bit too much weight, especially in some positions. So what I ended up doing is I rigged together a suspension system that was actually pulling the camera into the telescope, so it would have some support to fight against gravity. In 2017, there's another thing that we did was a switch before to open up the observatory. We had a toggle switch that would enable you to, it was essentially like a throw switch, right? So like you press it in one direction and it would open, then you would have to pull it back. It was very tiny, not very good. So what I did is, went to Lowe's, grabbed some parts, and I made a chair, right? Very basic. And it says open, close. I'm clicking the close button here, and there it is. It's closing. I'll fast forward to another spot, right? Because it's kind of slow, as you can tell. But there I click open and it opens. So this is great news for all the observers, because now they have something that's a little bit more sturdy that they can use. I'm gonna go ahead and close that window. And right, so we're at new switch. A year later after the inauguration, so this was May 5th of 2018 when we did the official inauguration, where we memorialized the observatory in honor of Dr. Cristina Valeria Torres, who had passed away just a few years before that. And so we actually just came upon the anniversary of her death. And so around this time I always think, and actually anytime that I'm working on any of these things, especially since she had a really strong like engineering mind, as well as this passion for sharing her love of science with everyone else. Like I always think of these things whenever I'm working on projects, or like sometimes I could just imagine like I'm working on something and she might have come over and like, why didn't you just do this? And then I think, yeah, that's probably what she would have told me. And yeah, so and this is now in 2018. In 2018, we also, right here, there's a paper clipping that shows proof that we actually did this. And this is a picture that I took of my copy. And so here you actually see Richard standing next to our first presenter, standing next to the telescope, along with hey, that's me. Yeah, so that's me. um, Yes, and Richard and Walton and Jorge, and he just graduated, and which is really cool. He's an engineer, and he's officially now. So congratulations. And now 2018 is the first remote access, and one of the things that would drive us nuts is that we had no internet access. So a lot of the things that we were doing there, we had to be prepared anytime we were going to do an observation. During these times also, I was not just doing maintenance and doing these engineering things. So along with Richard, we were also active observers. And so here is and this was during the summertime. We had two people visiting, or actually we had several people visiting us, but one of them this night particularly, we had Carla Giardini, a friend from Argentina. So hello, if you're watching. She taught us how to rough it as an astronomer, right? So another podcast reference. And here I'm actually controlling, you can see this is a MacBook, and I'm controlling that Mac with I'm controlling a Windows machine with my Mac. So here, how did we do that remote connection? On the left side is a picture of me standing between the park building and the dome, and you see there's a line. And on the right side, it's from the dome to the park. So what we did is we ran a cable and connected it directly to our computers. And so that's how we did our first remote observation. We had some issues with the position of the pointing of our mount since we were starting to do some more serious research that required more precision. We had a welder come install this thing, and so this is actually my dad. That it's so handy to have a welder as a dad, because then he can help us out with projects like this. And essentially, this thing would rotate the upper part of the dome, carrying all the weight of everything. So this was incredible addition to the setup that we had at that time. We also in 2018 had our first computer remote for the dome. And so this is all the processes that we had were manual. I mean, they were aided by the computer. No, not by the computer, but they were aided by electronics, right? So it wasn't just like we were cranking things, but like in order to rotate the dome, even now I'll say that like there's a switch. You flip the switch, and here you'll see we type in a command. We type CW, and when we click it, then I'm going to go out, and then you can see that the dome is rotating clockwise. And then we click enter, then it stops rotating. And I exclaimed that it's like magic. We were super happy doing this thing. And if in case you're curious, the electronics that were used, this was uh, uh, it's called a relay board, right? So here we have two relays, and we used an Arduino between that and the controller that controls the dome currently. Okay, now moving forward into the future, right? I guess closer to now. We received a new shipment. There was a new shipment, a lot of boxes. It was like Christmas. We opened everything up, and we put together this thing that we call a mini dome, and then we took it all apart. We just needed to make sure that everything was complete, and yeah, that was a lot of work, but it was a fun, team building exercise, as we call it. And we had another new shipment as well, and these crates are much larger than those cardboard ones, and this one was one that we were particularly excited for. And we call it, or actually I just called it that, at least for the presentation, like a new vision. But with that new vision, the old things need to be packed. And so this is the old 16-inch Meade telescope that we packed. We plan on using it again in the future, but not yet. So a new vision installed, and here it is. And there we are. And pictured, you see myself very happy and sweaty. Richard also happy and sweaty. Behind him, Americo. And at the very far end, we'll see Aldo. Hello, Aldo. I think I saw you in the chat active a little while ago. So I hope you're still here. And yeah, then we had to reinstall it because apparently the center of mass was too heavy with the camera that we had. So this is the mounting plate. And yeah, so that was a lot of work. After after we installed it, we had to take off the telescope and reinstall it. Okay. Now, there were some piers that we installed outside, and here you see, there's now just a few of them. You might have remembered if you ever went to any of the like public events that we had in the back. We had set up these. It's like a ring of what are they called? Piers. Actually, these are piers. These are the things that hold the telescopes with access to connect them to power. But we removed most of them, and here's one of the last ones. In the very Texas fashion, you might recognize those orange and white stripes. But here we have this auger that's drilling, because what are we doing? We're starting the farm, right? So we're starting the farm. The telescope farm is what we're beginning here. And the pier, in case you didn't know, if you're looking into doing some nice astrophotography or some of really deep sky things, so like very faint objects, um, you need something that's very sturdy. And one of the ways that we can do that is by just putting a lot of mass underneath the telescopes. So this hole is about 6 feet deep, and we filled it with concrete. So this is how we did it, right? And so the farm is growing, right? The concrete is poured. And I was involved through all the processes in each of these things since at least 2016. And then in our farm, we have our first sprout, right? Here, I kind of skipped a step between here and there. Here, you just see there's dirt around the outer parts, but we also had these brick pavers installed as well. And here, we're doing the installation of the mini dome. Yeah. And so during this time also, we had a symbol that came up in one of the devices that we use, and it says OC. And if you're an observer from CTMO, you might know this, and you know that OC does not mean of course. This was such a such a terrible few weeks, because there was a lot of troubleshooting that went behind trying to figure out why the OC signal was coming. According to the manual, it said is over current, whatever that means. Then we got another error message that says under voltage, whatever that means. Well, it means that for some reason there was too much current in the drive, so it just stopped working. And then under voltage means that there wasn't enough voltage being supplied to the drive. And we would be getting these two issues. And it turns out that actually the chip, the computer chip that sits inside this drive failed. So between Americo and myself, we became experts in the way that three-phase AC motors work, just to be able to identify how or how what issue caused this. And we came to the conclusion that it was a fried chip, but the only way to truly confirm was to send this out to the manufacturer. The manufacturer checked it, and they said, sure enough, that's a fried chip. So they helped us out to get that replaced. Now, getting connected, the farm needs a way to communicate, right? So we haven't said specifically yet, right, what the plan is with the farm, other than saying it is a telescope farm. And here is a rat's nest of pipes. So this is the way that we connect. On the left, these tubes, um, these tubes go into the observatory. Now, all of these other tubes that are coming in from the dirt are tubes that are coming from each of the mini domes, and so that was fun, connecting all these pipes and doing all this. Um, 2019 was a busy year. We're trying to do a big push so we can have our first guest remote observers. And here I am in a Zoom meeting with the big telescope. And this is actually a class that I had. I wear many hats, when it comes to CTMO. And one of them is engineer, and the other one is actually this. I'm one of the instructors for or facilitators for the Astronomy 1401 lab. And so this is one of the activities that we did. And so this was the first group that actually did this guest access. So people that aren't from our group were using our telescope and taking their own images. And Wendy was able to share some of those images. That wasn't from that group specifically, but yes, now the farm in full bloom. We're in 2020, and here it is. Now you might be wondering, or you might think like, oh, that's a nice shot. How did they get it? Well, our first attempt to get these shots, right, was on a ladder with a stick. And just because, right, since it's a state park, there's rules against using drones, so that wasn't good enough. And if only we had a drone. So we didn't get in contact with anyone. We just got a bigger stick, And that's essentially what we did. So there I am with the big stick with my phone at the very top of that. We use a binder clip if you're wondering. Now we have a new control room. When we're doing our observations, we're completely exposed to the elements. And here we have some netting, where the netting protects us from bugs, but not the temperature. So there is a new control room that we started working on. Here's one of the first walls, and you can see the design is in the back. But we'll keep on going. We have installation of the scopes, and what, these are the presenters you just saw right now. And so it's Wendy and Alex who just presented. They did the install of our first farmed telescope, and here it is. That's a dramatic pause, right? So yes. Um, Now, aside from that, there's also the tools that we have to use, right? So there's the environment that we're in, there's the controls that we use, but also the instruments that we use. And this all goes into the engineering. So, all right, so here we have this thing called the flat field, and photographers might be familiar with these kinds of things. But here you see I installed this light on a dimmer switch. And in order to get this thing that we call the flat field, we shine it onto a piece of just white space, a whiteboard, and pretty much it. That is the calibration device. Now we're almost there for our like today, right? So ASCOM, I talked extensively about ASCOM during the podcast, so I'll refer you to the podcast. Yeah. And but here I'm doing the installation. We hadn't had it installed on the new setup that we had. We had in a very old setup, and the idea with this is that we can essentially start making our transition into robotizing our setup. And during this time, we also have a new enclosure, y'all. So like this is really awesome stuff. I mean, it looks like a construction zone a little bit because it kind of is, but we have some nice lights inside, and we have walls that protect us now. And now it's this year, and we have a close sensor. So now when we close the dome, there's a sensor that will stop the dome from closing. The last bit here is ask coming soon. Yeah, maybe. uh, so we made a lot of jokes, about ASCOM and the different acronyms that they have. But oh, right. So here you see there's a sensor here, and this is one of the latest projects that I've been working on. And I'm working on developing a driver. So the driver is the thing that communicates between the instrument and the computer. And here I'm showing a demo that I did, just testing it. Right now you can't see the computer screen too well, but my expectation was to see squiggly lines, and those squiggly lines meant that I was actually counting the teeth on the gears. So let me see. Oh, there you see. There it is. And when I shut it off, there was no more gear movement. So this was a positive direction that we were going in the active process, right? So each of those spikes in the graph that you just saw was referring to each of these spikes on the gear that rotates the dome. Then revisiting pipes, I have another picture, and this was a picture of me next to the pipes because we only had one set of pipes connected. We had to connect the other one. One was for power and the other one's for data. And we have a room, and we had to paint the room. So we did a poll, with the observers, and we let the observers pick. They picked off-white. So this is a reveal for all the observers that haven't gone to the observatory yet. Yeah, we went with the off-white, and we painted it. And then we had the data connected. So we passed the lines through, and now there's an Ethernet cable from that first telescope that's already set up inside into the switch. So we're almost there. Now we just need a computer to speak with it. And which leads me to yesterday, March 19th, 2021. We installed a mini split inside the control room. Yes, now we have a controlled weather environment inside our enclosure, which is great. Now, for the future, we want to be able to control, or we will control the mini domes remotely. It'll probably happen, the first one by the end of the year. We plan to have at least, hopefully, 3 fully functioning connected mini domes. But for sure, we'll have the full set within, the next few years. And 2030, we'll have observatory technicians monitoring the status of the telescope farm, aiding guests in the remote observations. And, the observatory and the telescope farm, when they're not in a like manual use, we want to have them just running autonomously, where the objects that are being looked at are optimized based on just the research needs. And as Alex was saying about those transient alerts, if we were to receive one of those alerts, or maybe an alert from LIGO, the Laser Interferometer Gravitational Wave Observatory, when there's a gravitational wave detection, we would cancel all the other observations and look specifically where those alerts were coming from. That way we can contribute to some great science. And then that's all I got. Thank you.
Great talk, Moises.
Thank you.
You mentioned
I love that slide. It said, sorry, go ahead.
I was just going to say you mentioned ASCOMing, but not POTH. So I was just dropping that there.
Yeah, so POTH is for the older generation, and that was the older method for one of the methods inside of ASCOM, but they have since gotten rid of POTH, and now they use this thing called Device Hub. And but we used to think that the possibilities were endless with ASCOM. All right, but
if you want to hear more of that, also the podcast. No, but I did on the YouTube chat, I did put the link to where the podcast can be found. So yes, I think I loved that slide with the 2020 n, where n is an integer number greater than 1 but less than 10.
Oh. Oh yeah, I didn't read that, but if you saw it, you got it.
Awesome. Are there any questions? I don't see any in the chat right now. But while we do wait for any to come by, I just want to say, well, yeah, amazing presentation, Moises. And I want to emphasize, I think everybody should go ahead and listen to that podcast and all the other ones on there. But on this podcast with Moises, I did learn a lot about this observatory, and now I learned a lot more, and I didn't see some of those images before, the newspapers and the videos, and it's really amazing to see how much this observatory has grown. And I mean, I myself, I only came in through the Astronomical Society a few years ago, towards the end of 2018, beginning of 2019. Before that, Carol Lutzinger was the leader of the Astronomical Society for more than 20 years. Before that, she was there. But now, and so I'm learning a lot about this observatory. And one of the things that I'm continuing to learn about is how dedicated everybody is, and especially Dr. Diaz and the entire observatory group and all of you, to the outreach and education. Yes, it is an astronomical facility, and they do great research here, scientific research and cutting edge astrophysics, but the education and the outreach is something that has always been emphasized. And every time we talk, I'm learning more and more about that. And so so thank all of you for speaking and for letting me and the South Texas Astronomical Society be a part of it, and be a part of sharing that with the community, because in the end, that's why we're all here. And I think that's something that's brought all of us a little closer together. And I mean, there's some really great stuff going on here, and our goal is really just to share it with everybody in the community. And so today we had this event on here today because it is March 20th. It is the first day of spring. And so this was our way of celebrating it, talking a little bit about, well, spring and the spring night sky, but also about the observatory and a lot of the great stuff going on here. And yeah, I thank you everybody for coming. And one more time, because I have to say it, if you would like to donate and help STARS continue programming and science education for the community, please consider going to our website at starsocietyrgv.org and donating there. And so with that, we'll go ahead and end the event. And thank you everybody again for coming out.
Thank you, everybody.
Awesome.
Now for the after Zoom party.
There you go. I just